this one. There, your share thing is lighting up right now.
I think I had to move it over here though. Okay, did it work?
Yes, perfect.
Okay, great. All right. So I thought I would start the presentation by talking about the science and the research that we do. And then Sarah is going to focus more on the citizen science aspect of this, since you guys are all highly engaged citizen scientists. And I think that we have been trying to expand this beyond the Elwha system, and are really excited to have a conversation with you guys. And we will definitely leave enough time at the end for us to chat and see how we can better connect with your group. So the core mission of most of our research is to determine the impacts of anthropogenic effects on the environment. And so we want to help improve habitat and conservation efforts to create more salmon, primarily as my job. And the recovery allows, for as members of the Department of Commerce, for us to increase production for commercial fisheries and tribal fisheries and sports fisheries and the like. But today I wanted to focus more on, we're really interested in salmon as a whole member of an ecosystem. And so the forage fish are a big component of that. So basically the take home message is I do a lot of field and laboratory work to figure out how we can help the plight of salmon, and as that applies to our constituents who are interested in catching those fish. So historically, I think when salmon started in their decline 50, 60 years ago, or even longer, we took a really piecemeal approach to looking at salmon. And so we tended to study the 4 H's. We looked at harvest. If we could decrease harvest, would salmon improve? If we made more fish in hatcheries, would that improve? And all that little piecemeal approach didn't really make as big an effect on improving salmon condition as all the money that we poured into it seemed to think. I won't show it to you guys, but later, since if you're watching this and you have my slides, that link at the bottom is a little link to a presentation by Billy Frank Jr., who was like the Rosa Parks, I think, of the Native American community. And he had a very good sort of broad picture approach to how we should manage fish as members of our environment. And I encourage you to watch that little cartoon. It's pretty interesting. So again, like I said, this piecemeal approach didn't work. And we really, as scientists now, show that we need to take a whole ecosystem-based approach to management. We need to look at the entire food web and all the things that are affecting salmon, not just salmon. And forage fish are critically important at Puget Sound and the Salish Sea because they're the big part of the triangle, the bottom of the triangle for our food web. And that influences not only the salmon, but also like the listed orca whales who depend on the salmon. So the way that they move the flow up of energy up through the food chain is really important. And we haven't spent a lot of time focusing on them or on plankton species. And I think that the community has all come together and really seen the importance of taking this bigger overarching approach, especially in light of climate change. And if you're not familiar, Puget Sound Vital Signs is we're trying to take a whole look at the Salish Sea and see which drivers are most impacted and what things we can repair or remediate for habitat, especially to help improve the plight of birds and forage fish and for humans that are using all of these parts of the system. So again, this is a pretty user-friendly website down here at the bottom, and I encourage you to check it out and especially spend some time looking at the forage fish section because I think it might pertain to your interests. And again, like we talked about, not only are forage fish important food source for salmon, but we've also seen big declines in them, which could indicate a future problem for the whole ecosystem that would have negative impacts on other species, including the salmon. So Cherry Point is a good example in your neck of the woods. We've seen huge declines in the Cherry Point, which used to be one of the biggest herring production areas in Puget Sound. So we have done some research in that area, and I didn't have enough time to pull all of that together today, but I wanted to talk about a really successful project that we are doing on the Elwha River that has given us an opportunity to take a closer look at forage fish and to see how they influence successes of systems. So, for those of you guys who aren't familiar, it's just kind of across the water a little bit from where you guys are. Out in Port Angeles, the Elwha River had one of the largest runs of the biggest salmon in the Salish Sea. There was often salmon documented to be over 100 pounds, and this sustained several tribal nations. It is now, Elwha now runs through the Olympic National Park, and some of it is on tribal land. However, they put in 2 dams to help for energy, for production, for logging, and other things for the town, other sources of energy for the town. And those dams were no longer efficient. So they decided to remove those dams to allow the fish to have access back to the system that they've lost, because when those dams were installed, basically those runs of giant fish in high numbers just went away. And then here, for those of you who aren't familiar with the Elwha Dam removal, they removed 2 dams on the system to restore access, and both of those links right there from the National Park Service that give you sort of a really great video and infomercial on how they removed it. One of the biggest considerations is, even though these were in freshwater and fairly far upstream and wouldn't have impact on adult fish, they were adult forage fish. We were really concerned about if all the sediment was released suddenly into the near shore where herring and smelt and sandland spawn, that it would wipe out that whole population. And we really wanted to conserve that. So there was a lot of thought and effort that went into stepping down these dams in little chunks and to release the sediment in smaller sections so that it would not have as big an impact on the spawning habitat of forage fish in the near shore. And also the turbidity wouldn't cause for fish kills for salmon who are hanging out in the system. We encountered a few little minor roadblocks. One of them was after they removed one of the dams, we had a boulder kind of fall in the system, and they had to blow that up. And that event led to some discharge that wasn't like planned or anticipated for, but it wasn't really as negative as we thought it would be for the salmon that were for the forage fish that were spawning at that time. So again, just to give you a little picture, up at the top of the screen, you'll see the mouth of the Elwha River, and then the first dam is clearly marked right there. So that was the only section that salmon had access to. But also you see to the left of the mouth that's called Freshwater Bay, and that had been historically a pretty significant place for herring and smelt to spawn. So I'm really interested in the nearshore system. Sarah does quite a bit of work in the freshwater system. But like I said before, those 2 dams made significantly large reservoirs that held back a lot of the sediment. So we were really careful about how to release that. Again, here's sort of a picture of what the reservoirs and what the system kind of looked like with the dams in place on the left. And then we're moving towards a more normal river system on the right that is hopefully going to release sediment, continue to release sediment in more normal ways. Here is the nearshore, which is a critical habitat for forage fish. And as you can see right here, it looks kind of like an I-5 freeway system. Because it was so sediment starved in the nearshore, we had a lot of salmon just heading out in big boluses that were released from the hatchery. And we were unclear like if there was enough food availability for them when they were just kind of released all of a sudden like that. So some of the sediment as it moves helps make a fan sort of shaped thing in the lower estuary, which gives a lot of habitat for salmon to hang out in, but also improves the spawning success of herring and smelt in the area. So originally, my science was salmon-centric, and we started what's called a traditional backy design. We don't really have a great control for field work out in the Strait of Juan de Fuca. It's not really accessible, not a lot of the areas accessible by small boats. So I kind of changed that to a reference. But basically, we wanted to monitor 10 years prior to dam removal, during dam removal, and after dam removal to see what the impact would have on the entire fish community, including the salmon, forage fish, and all other fish present. We were interested most in the nearshore changes, like if we do see sediment restored to the starved nearshore, would that improve the spawning situation, especially for herring and smelt, which have really specific and differing requirements on how fine the sediment can be. And then also we're interested in the long-term changes throughout the whole system. This is a landmark restoration effort. And so usually a lot of the work I do is remediation. The difference in that being is that we were trying to return the system as close to the natural process as possible, whereas sometimes most of my work is remediation is just to make things better. So this is kind of a once in a lifetime opportunity to study how the entire area is going to benefit from a restoration process. And again, here is the Elwha River. Port Angeles is one of our sort of sites that would be influenced by the sediment, but not as heavily as the right next to the Elwha River. And then we picked some other reference sites farther east that would not experience the sediment loading. And the method that we use is beach seining. So we set a net perpendicular to the shore and we pull it in and we count and identify and do links of most all the fish that we catch. And that's all fish, including forage fish, salmon, everything, because we were also interested in how the communities might change. For example, Freshwater Bay had been pretty sediment starved and had a lot of cobble. So there was a lot of kelp in the system. The kelp liked to attach to big rocks on the bottom. And we knew that the sediment would come out and probably wipe out that initial kelp, and then it would slowly recruit back. But we were interested if eelgrass would come back to that system, because prior to dam removal, there was a lot of information that indicated there was eelgrass in that area, and that supports a different community of fish. So we're interested to see if sometimes if the communities change, it gives us a good idea of how fast the restoration process is going. We only sample for 6 months out of the year because the weather is so adverse out there and it's too rough to sample a lot of the time. There's some overlap in our April through September sampling with forage fish, but we know we're going to miss some of the early and later spawning events. We tend to get about 22 different fish species in the nearshore. And if you are interested in improving your fish ID, we've made a great guide for our citizen scientists and the beach watchers. And we've taken like fish guides and made them in English so that it's easy for lay people to understand and how to tell the differences in some of the fish in the communities more easily. So if you're interested in that, I'd be happy to provide that information to you. So again, our questions in terms of forage fish, which I think you're most interested in, is how the abundance and community composition changed. Were there changes over different years and months we sampled? So again, I sampled from 2006 until last year. And that sounds like a long time, but there's a lot of variability in storm surges and other things that influence the forage fish community. So we were really worried that we might not be able to see the signal of dam effects. And if you want more information on any of this that I'm talking about today, at the bottom of this slide is a reference to our paper that just came out, I think last year, documenting this in great detail. So again, the cool thing about the nearshore in the Strait of Juan de Fuca and Port Angeles is that forage fish do really dominate. So if you look at the orange right here, and all of these, that's all the forage fish species. The salmon are in green, and some of the salmon numbers are arbitrarily high because we sample in areas where they release a lot of the hatchery fish. So a lot of our salmon that we catch are big groups of hatchery fish that are heading out. And then I didn't want to spend a lot of time on the data, but I wanted to make sure to include it in the slides for you guys. So basically here is all of the major forage fish that we catch. I think mostly in your area, it's mostly herring, smelt, and sand lance, but we also get some of the transitional species out in the Strait of Juan de Fuca, which include things like northern anchovy, longfin smelt. Night smelt had originally been thought to be an ocean predominantly ocean-based fish, and we were able to document clearly that they're using the Strait of Juan de Fuca in significant numbers. And we have another paper out on that. I also included in things that act as forage fish, like shad, which are an introduced species in our system, but sometimes they outcompete for habitat with salmon. So I was interested in their numbers. What's interesting, if you are following like concerns about climate change and that thing, we're really interested in some of the like northern anchovy and other species. A lot of times when we have years when herring and smelt production is low, we see more anchovy. So that might indicate that there are some habitat restrictions or carrying capacity in the system that might be driving some of these dynamics. And people who are interested in climate change are really interested in how changes in the climate, especially out in the Strait of Juan de Fuca, could have an influence on decreasing habitat available for forage fish. Okay, so this is the average catch per unit effort of forage fish that we catch in the 4 different regions. And again, I think it's really interesting to note that sandlants are pretty patchy. I'm most interested in sandlants from a research perspective because every time we catch salmon, we'll catch them in schools of smelt and herring often, and they'll still only have sandlants in their stomachs. So for some reason, they are preferentially choosing to eat sandlants, even though smelt have been shown to be an easier prey for them to catch and more abundant in some of the areas there on the water column. So there's definitely a nutrition or some other driver that is choosing them to choose sandlants, but we know very little about sandlants in the Strait of Juan de Fuca. One thing we've just recently discovered is that there seems to be 2 genetically distinct groups of sandlants in the Strait of Juan de Fuca. There are some that tend to spawn and hang out only in these, what we call deep sand fields in the main part of the system. And then there are some that do come up into the near shore that we catch in beach stains. Beach stains are a hard way to study forage fish because forage fish are very patchy. They tend to, either you catch them or you don't. And some of it's luck of the draw and if you're in the right place at the right time. So sometimes that makes it really hard for us to use beach stain to make assessments about the success of forage fish in the near shore. And that's why it's so critical that some of the work that I think you guys are doing, and we have similar partners that are doing in the Strait of Juan de Fuca, going out looking for spawn, looking for eggs, seeing if that there are adjacent spawning areas. There had been clearly documented spawning areas, like I said, in Freshwater Bay and the Strait of in other parts of the Strait of Juan de Fuca, like in Squim off Discovery Bay. And those seem to have disappeared for a while. And I think some of them are slowly coming back. But we still in the beach stains catch a lot of very small juvenile and post-larval forage fish. So they have to be, we would assume they were recruiting from somewhere nearby. And we are just not aware of where they may have shifted their spawning locations. So I think it's really great for the members of the public to know that we're interested in that kind of data and to give us or WDF&W a call. If you see spawning events on your local beaches or you see eggs, we always are really great about appreciating pictures or requests from the public to help identify things that they see on the beach. Let's see. Again, it's interesting also to note the differences we see in some of these areas like Greenpoint. We tend to get a lot of smelt. And the reason that is because Greenpoint is a feeder bluff. So we have a lot of sand and sediment released, and the surf smelt tend to like the smaller sandy surfaces to spawn, whereas the herring, their preference is for slightly larger grain size. So we know that some of these things are driving the system. So in saying that, I would anticipate that perhaps in the Elwha, as the sediment moves downshore, we should see an increase in surf smelt. Okay. Everybody is always interested in sandlance, surf smelt, and Pacific herring because they are a majority of the biomass in these systems. But I also included, if you notice, the scales are really different from that first figure A and B, much smaller for the other ones, but just for you people that are interested in the other not popular forage fish, I included that data in this talk. Okay. This is sort of messy, but this is some of the things that we're trying to deal with our science. We are keeping track of the size distributions of forage fish throughout the seasons and throughout the years. And again, the main reason that we're doing this is if we continue to catch small fish throughout the season in the area, it implies that there are adjacent spawning beds that we need to work a little bit harder to find and to monitor and to make sure that those areas are sort of protected. Additionally, it's only 4 miles across to Canada, and Canada has a pretty robust herring fishery, and they have a lot more spawning location over there. So there's some indication that the herring are coming across from Canada. And this again talks about the importance of us needing to manage across international waters and to work with the Canadians, because the fish, especially the herring, don't seem to know the borders. And it's really important for us to make sure that, like, if they still have a fishery and we close our fishery to protect ours, they may still be catching some of our fish. We're doing a lot of work with genetics on this to try and determine if there's genetic differences in the different populations and if we can see where the fish are coming from. It's been really interesting to note that we have seen fish in the Strait of Juan de Fuca that are more closely related to fish we see in Elliott Bay, which is deep in Puget Sound, rather than more closely related to some of the Canadian stocks. So it shows that some fish are coming from quite a distance. And also, we are interested in spawning time of these fish in light of climate change. That's sometimes an indicator of some events that are influencing fish communities. And we want to make sure that the fish are continuing to be available as prey for a fish like salmon throughout their migrational history as well. I put this in just for fun because we have started other ways of looking at fish in terms of just the straight statistics. So one way we look at fish is these MDS plots, which I'm not sure a lot of the public has seen, but I really like these conceptually, and they're great when I give talks, because the point, all the take home for these sort of plots is the closer a point is to another point, the more similar it is. So you don't have to interpret a lot of the complicated graphs in that messy like length distribution graph I just showed. So we can run, for example, lengths of fish and see if they're, most of the fish are small in certain areas or most of the fish are big, or look at how related they are by other factors. And again, the biggest problem that I'm seeing for the Elwha is that there's so much noise. There's a lot of storm events. There's a lot of high tides. There's a lot of things that make it really difficult for us to see the signal from dam removal. And again, that plays into the citizen science request piece. Many of us are getting closer to retirement age and are losing our funding for some of these long-term monitoring programs. And so Sarah, I think, might mention this, but we're working really hard to try and engage citizen scientists to continue to collect some of our data so that we have this great look back in time to see how some of these big restoration events continue to improve the systems for 20, 30, 40 years until they reach their true equilibrium and they're back to their initial conditions. To try and separate the signal from noise, I'm an ecologist and I just look at math in general. I can barely balance my checkbook. So I work with a lot of mathematical modelers who develop models to try and see if like the patchiness of my data is driven by some other factor or other ways of looking at the data in a more robust manner to give me some indication of some signals that I haven't met, some things that are influencing forward fish that I might not be aware of. And I'm not really good about speaking to this model, nor do I think we have the time to talk about this today, but I just was going to mention that this model is in our paper. The biggest thing from the model I wanted to bring home is that we tried to look at before and after dam removal for all the areas. And again, the Elwha and Port Angeles were probably most influenced by the dam removal currently up to date, and the others haven't been. And so far, we haven't really been sampling long enough, I think, to make really good predictions on what is going on for forage fish. But one of the things we have seen again is that the surf smelt seem to have improved across the system, and maybe even a little bit more where they're getting more sediment input. So again, in my research, we catch a lot of fish, but a big majority of those fish are forage fish. So I think you folks being interested in forage fish is a great thing because they're obviously super important to our ecosystem. And we want to continue to sample in any way we can using citizen science, using automated devices, using cameras, any ideas that we have to continue to document this and to see how forage fish are improving not only in Port Angeles surrounding dam removal, but also throughout the whole system. And right now I'm working on trying to tweak the model to give us some kind of assessment about how salmon are faring in this system. We also want to look at continue to look at genetics and stable isotope to get some idea of how long forage fish are hanging out in the areas where we're seeing them, and if they're coming from greater distances, like I talked about a little bit earlier. And I really want to say that I appreciate we've had a lot of tribal partners, federal partners, state partners, and we take a lot of volunteers aboard our vessels. And there's only 2 of us that have been dedicated to this nearshore sampling. And so it's been really great getting to know people from different walks of life and giving different input and helping us just to make this a success. And so from there, I think I'm going to pass this on to Sarah, who can talk a little bit more about the citizen science piece of that.
All right, thank you, Anna. So I'm going to so Anna gave a really great overview of some of the nearshore monitoring that she and others have been conducting on the Elwha for the last 20 some years now. And I'm going to kind of take a step back and talk a little more broadly. I'm not going to really get into specific data plots or anything, but just talk about some of the things that we've been learning from the Elwha about how we can do a better job of trying to do long-term restoration monitoring and ultimately make better management and conservation decisions. So I'm going to be talking specifically about some lessons we were learning from the Elwha, things that we're trying out, but it's applicable to many other areas. So this summer, a number of us who've been involved in Elwha research monitoring for a long time came together for a science symposium. And we've been having these periodically for a couple decades now. And many of the folks who've been involved in this research have been doing so for 30 some years and are getting ready for retirement. And 2022 was also a special year because it marked the 10-year anniversary of the dams being removed. So we had kind of 4 primary goals when we came together for the symposium. One was to try to share data amongst all these different scientists and collaborators. Another was to try to synthesize information at a broad level and communicate that to the public and to policymakers. And then we also wanted to try to plan for information transfer to ensure that this monitoring keeps happening for decades. Projects like the Elwha Dam removal don't come along that often. And we also know that ecosystems, some responses we see very rapidly, but others are going to take decades to evolve. So as the salmon start to be reintroduced to areas that they once inhabited, it's really going to be decades to see how the ecosystem responds. So how can we ensure that the science keeps on going forward? So 2 other big goals that came out of this symposium were to make sure that data was publicly available and accessible to everybody, to members of the public, to other scientists, and it was archived well. And then the other goal was to really start incorporating more community and citizen science in a more strategic and organized way. There's certainly been a lot of community and citizen science involvement on the Elwha over the years, but we just want to try to find a way to build that up even more, because I feel like that's really going to be the key driver to make sure that this research keeps going forward. So here are some of the logos of many of the groups that have been involved in monitoring over the years, and probably have inadvertently left off a couple. So one big effort that happened recently was that there's been a lot of publication on the Elwha, and happily, it's all now in one place. So it's in an online database that's anybody can look up. It's called Zotero. I'll provide a link at the end of the talk. But you could also just type Elwha and Zotero into your web browser, and this will pop up. It's got well over 100 papers. So things that are in the formal literature and scientific publications, but also perhaps even more importantly, there's a lot of gray literature in here. So a lot of like the reports that only get circulated internally that have a lot of the raw data that are hard to get your hands on. It's now all in this one central place in this bibliography for everybody to see. Another effort that we have been working on, and I'm going to talk specifically about NOAA because that's the agency that I work for, but other groups are also undertaking this process, and some are further along than we are. So for example, USGS is very involved in many aspects of dam removal monitoring, and they have done a pretty good job of really doing public data releases. So it's generally a little easier to track down data from USGS, but not so much so for NOAA. So we've been trying to correct that, and we've been working with some of our science data management team to develop a public data portal. It's not quite live yet, but it will be soon. So it's meant to be one place that members of the public or anybody can go to, and it gives you a little bit of background on what we've been doing in the Elwha. We'll have links to all of our partners that you can click on and see what kind of data they've been collecting and how they're involved in the research. And then it also has links to all of our various data sets. So we've been collecting data on many different facets. So in the lower, in the middle, on the bottom in the middle, you'll see a fish in the near shore. So for instance, that captures all the data that Anna Kagley and Kinsey Frick and their collaborators have been collecting. Up in the upper right there, riverine food web, that's a lot of data that I have been focused on for the last decade or so. And then there's other areas that we work with other people on. So those are all getting populated right now so that anyone can go in and download those data sets. And I'm gonna just focus a little bit now on some of the data sets that we've been most actively involved in citizen collaborations. So one of those is water temperature. Water temperature really lends itself well to working with lots of different collaborators. It's relatively straightforward. We have data loggers that we install in the river across a wide network. However, it's a pretty big watershed, and a lot of it's in the backcountry. So we have, something like, we have over 20 data loggers at this point, and we'd like to have many more. Some of them are hard to get to. And also the river system, the flows are constantly changing. So we're based in Seattle, but we need some help of people who are closer there who can go download them more often, or if the river is really low at the end of summer, they can move them out into the water column, or if there's a big flood event that's predicted, they could potentially move them out so that they don't get swept away. We do have some loss of equipment during really high flow events periodically. So we've started working with a number of different volunteer groups, community science groups like Clallam County Stream Keepers. We've also, on the left here, started working with professors and students at Seattle University. So this is a field trip for some environmental science students at Seattle U that came out this last summer, and they also came out in the fall, and they're helping us download loggers that are not road accessible, so that require hiking in beyond the Glines Canyon Dam. And as soon as that data is downloaded, we can upload it into the database, so you can immediately see see what your data that you've collected and how it's contributing to other projects, and make it available to other researchers. Another program that we've been starting to pilot in terms of involving members of the public is some of the benthic invertebrate monitoring we've been doing. So that's collecting mayflies, stoneflies, caddisflies, other invertebrates that reside in the freshwater and are primary food sources for salmonids in their freshwater portion of their life cycle. So we've been sampling invertebrates as well as periphyton, which is the slippery stuff that you slip on when you cross the river. It's on the rocks. It's a matrix of fungi, bacteria, algae, sediment. And we are now starting to involve student groups that come out and work with Nature Bridge, which is an environmental education institute based in Port Angeles. They work with student groups from all over the country, really. A lot of schools from Seattle and elsewhere send their students out there. They get students from, this group is from Texas, actually. They also work with local school groups. And what we're trying to do with them is have them focus on, target a few different invertebrate species that we've been looking and using for stable isotopes, which is a way of tracking the return of marine nutrients from salmon as the populations begin to rebuild. Another exciting development in the, building the community and citizen science component of Elwha Research is that we just recently hired our very first Elwha outreach coordinator. That's Chelsea Bamer, pictured here. She's a PhD student finishing up her dissertation at Oregon State University. She's also worked previously for Nature Bridge, and she's doing a one-year internship with the Lower Elwha Clallam tribe to serve as their outreach coordinator. And we're hoping that this is going to be a position that we can continue to fund. So we have one central person who's going to be developing a website where people can go to get information about all the various projects that are happening, how to volunteer, and also learning from the community what questions they are interested in. So it's not just a top down, but it's also more of a bottom up collaborative process and how we continue to monitor and measure the success of this major restoration action. So I'd just like to leave you with a couple spots, places where you can find additional information if you're specifically interested in learning more about the Elwha or perhaps getting involved in some of the data collection efforts. The barcode, thank you, I'm losing my words, which is not unusual. On the left is a link to the Zotero bibliography. And so you can take a picture of this if you're interested in following up. And then on the right is a citizen science survey that was developed by an intern that was working with us this last summer. And it'll take you to a Google survey where you can fill out information about things you might be interested in participating in. And then that goes to Chelsea. And then also there's an email there at the bottom now, which is Chelsea. It's a way to contact Chelsea or whoever takes over next year if you want to get looped into additional activities. And I think that's all I have for now. So we've got, I think, 15 minutes for questions. If anybody has questions for me or Anna, I'll turn the screen here and let our facilitator take over again.
Should we stop sharing?
Yeah.
Yes. No, thank you so much. That was so so good and informative. And I can always tell when we have presentations from scientists in particular, they get really excited about the data. So it was really cool to see some of the more nuanced and finer details. So thank you so much for that. If folks have any questions, you're welcome to type them on the chat, or we're a pretty small group. You could raise your hand and come off mute if you'd like. I'll start us off with a question that came up for me. It's just kind of how you move from translating all of this data that you're collecting with these long-term monitoring projects, and then how that gets translated into policy, especially up at the level of NOAA. It's okay, how do we when is data conclusive enough to say okay, now it's time to do something about it? And then do you also work in the policy realm, or does get passed over to another group? How does that work?
I'll take the first crack, and then I'll let Anna take another crack. That's a really good question, and Destiny, and also
we can't answer that some days,
and also a hard question to answer. Yeah, there are there are different groups that handle the policy making, but of course they rely on the science to help inform those decisions. But as we management decisions are based partially on science and partially on lots of other factors like political will and constituents' desires and all those sorts of things. But I mean, the Elwha project is a pretty high profile one. So there have been a lot of eyes on it. And for instance, hopefully folks have read about what's going on in the Klamath Basin. So the Elwha was the largest dam removal to date in the world, but now the Klamath dams are in the process of coming out, and those are even larger. And there's five dams that are coming down. So for instance, what's being learned on the Elwha is being watched very carefully by Klamath Dam, people in charge of removing those dams. And there's been a lot of collaboration, and they've come out here, we've gone down there. I'd like to think that, the success of the Elwha dam removal perhaps played into getting the green light for saying, yes, let's try this in some other areas. That's a little bit of a diffuse answer. I don't know if Anna wants to say more, but.
I mean, I would say that is like Sarah alluded to, the politics piece is a factor that we as scientists don't have to always consider, which our regional partners do. So a lot of times we give our data to other NOAA partners and other offices that are in charge of like the policy and management piece of it. And then they take that and then take whatever laws and policy that they have to implement and try and come up with a good compromise. I think one thing that was really interesting about the Elwha dam removal is so many of us were all on the same side until the dams were removed. We were all about like, let's get these out, let's restore the environment, let's do this. And then, we had some really complicated conversations that involved a lot of policy. Like the tribe really needs production, and their livelihood a lot of times depends on salmon. So they wanted the salmon to come back as rapidly as they could. So they wanted to do a pretty heavily stocked hatchery program. Some of us as research scientists would like to see how, given this once in a lifetime opportunity, how wild fish will recolonize on their own. So sometimes we had to have some pretty hard conversations. Another good example is the coho were not getting up into the system fast enough. And so there was some talk about us taking them in helicopters and dropping them out. But the national park, really protects their airspace and wants everything to be quiet and a great experience for the hikers and people who use that system. So a lot of times these policies collide in ways that we never anticipate. And it's been, in some ways, great. We've had some great conversations about what drives our choices in policy and how we prioritize things. And I think vital signs has been a really good way to also look at that. Like, okay, human benefit of just going out in nature and seeing a salmon is just as important to someone as someone catching one to eat. So some of those things we've really tried to work with and be mindful of with our agency partners and the people that make the rules and regulations to make sure that everybody's best interests are represented although nobody wins and nobody loses 100%, right? So
Well, sometimes people lose 100%.
Yeah, sometimes they do. Okay. I'd like to think they don't. I'd like to think we could all come to a compromise, but yeah. It's been a very difficult, Whenever salmon or orcas are involved, it's a very difficult decision for managers.
Yeah. Okay, thank you. I see we have a question from John. If there is a lot of noise in the nearshore data sets, does that suggest dam removal wasn't a major event? So I don't know, WRT.
Yeah, I understand what he's saying.
Okay.
Yeah, I understand. So yes, for the freshwater ecosystems, it's a huge bonus. And to give actual habitat back to salmon, it is huge. But the impact that it may have on nearshore fish communities is probably small compared to so many other factors going on in that system. I would anticipate, but I don't know. And again, that's kind of the importance of these long-term monitoring systems. Yeah, it's interesting that I kind of got roped into this dam removal because at first it wasn't really on my radar because I am a nearshore and sort of saltwater person, and they're removing freshwater dams, So, but I think it's been great because we have kind of taken these piecemeal approaches to salmon in the past, like I said earlier. And so it was really great for me to work with Sarah and see what, freshwater drivers are limiting for salmon versus they're something completely different in the near shore, and how we try and like fuse those to give salmon the most bang for their buck has been, I think I've really liked working with people from different habitats.
Yeah, it's been a really great example of interdisciplinary work and an opportunity for people to get outside of their boxes.
But yeah, like that question is, you're right. I mean, I think for the near shore, probably once the sediment has already come down and stabilized and as much as it does. I mean, the sediment's always moving in the near shore. This may not be as a big impact as we thought it would be. We came up with some really interesting findings, though, that we did not anticipate. One of the things is in all those reservoirs that I showed pictures of, there used to be forests, like cedar forests. And so they cut down all the trees, and there were huge stumps that have been under there for like 60 years or however many years. And a lot of the wood chips and stuff that were held back there from those trees rotting in the systems or whatever came down into the nearshore. And so for like the first couple seasons, it looked like the nearshore had been bark dusted. It looked nicer than my yard ever looks with mulch. And we were really interested in how that would affect some of the food that, like some of the invertebrate populations. And we hadn't anticipated that there would be significant changes to the invertebrate population, but you know, we were making estimates based on sediment and not on wood. So that was just one of those interesting things that came up.
Okay, we have time for a couple more questions. I had a question about what you mentioned briefly, just either, I don't know if you said the need for or already existing collaborations between us and Canada around what's happening. Is that collaboration happening? Can you speak a little bit more to that?
Yeah, we have, especially Washington Department of Fish and Wildlife primarily manages forage fish, and they have had some of the best conversations the last 5 years with Department of Fish Oceans, who also manages on their side. And we had basically shut down our entire fishery for herring here in the Puget Sound, except for a few really small events. And they still have a pretty, they still have a fishery in play, a noteworthy fishery. And so, but they were really responsive to some of our concerns about, hey, if the fish are, you know, if we stop all of our fishing and you keep it going, are we, you know, sharing the same fish and you guys are going to get more than your fair share? And they've been super responsive. And so some of their fisheries they have scaled back, especially in light of our Cherry Point conversation. So yeah, I would say it's been really overall pretty positive.
Great. Do we have any other questions? All right. Okay, well, thanks. Thank you so much, Anna and Sarah, and thank you to everybody who attended today. Again, this is being recorded, so this will be put up on our North Sound Stewards YouTube channel. If you signed up, we'll send you a link to the recording as soon as we have it up. Yeah, but thank you so much for taking the time to present.
Yeah, and you guys are welcome to reach out to us anytime if you want to work on citizen science. We're the people that are trying to drive citizen science forward a little bit in our agency. So we're happy to help any group that needs direction for resources or links. So
Definitely. And thank you for the invitation.
Thank you.
Yes, thanks so much. Right, bye, everyone.
Bye.